The next property of exponents I want to look at is called the power of a product property. There's a few things about powers that we already know. We know how powers work, that if I have 2 to the 4th power, that's 2 times 2 times 2 times 2. So the base multiplied by itself 4 times, right? And that should give us 16. When we're looking at the product of powers, that's when I have one exponent, n to the 4th, times another one, n to the 2nd. And we saw that to simplify that, all we have to do is add those powers together, and that will simplify to n to the 6th. And the third thing is that we have power of powers. So if I took a power, like p to the 3rd, and raised it to another power, how we simplified that was to multiply these two powers together, p to the 21st. So what if we're going to simplify tw to the 3rd? Now we can use what we know about how powers work, that tw to the 3rd is when we take the base, tw, times itself 3 times. And if you look a little bit closer, tw is a product. So we really have t times w times t times w times t times w. And one thing we know about multiplication is that order doesn't matter. So I can rearrange this however I want, like t times t times t times w times w times w. Then we can rewrite this t times t times t as t to the 3rd, and this one as w to the 3rd. Let's take the same approach on something that's a little bit more complicated. But if we have 2xy squared to the 4th, that's each of these are being multiplied together. And we're going to take the base, 2xy squared, multiplied by itself 4 times. So 2xy squared times 2xy squared, 2xy squared, and 2xy squared. So there's 1, 2, 3, 4 of them. Since everything is multiplication, remember that's 2 times x times y times 2 times x times y squared times 2 times x times y squared times 2 times x times y squared. So I can rearrange this to collect all of the 2's right next to each other. And there are 1, 2, 3, 4 of those 2's. And I can collect all the x's right next to each other. X times x times x times x. And all of the y squareds too. So we'll have y squared times y squared times y squared times y squared. We can rewrite all of these as their own powers. So 2 times 2 times 2 times 2 is 2 to the 4th. Same thing with the x's is x to the 4th. And same thing with the y squareds is y squared to the 4th. We can take one more step of simplifying. 2 to the 4th is 16 x to the 4th. And y squared to the 4th, since we have a power to a power, we multiply them together and get y to the 8th. But what's real important here has to do with the line right before it. Notice that when we started with 2xy squared to the 4th, so everything was taken to the 4th power. How we handled that is we took 2 to the 4th power, and x to the 4th power, and y squared to the 4th power. So every one of those factors inside of the parentheses got taken to its own 4th power. And that's what we call the power of a product property. That if we're multiplying on the inside, now notice this only works when it's multiplying on the inside, but if we're multiplying a couple things on the inside and then taking it to a power, what we could do instead is take each factor to its own power, and then multiply those two together. So what I mean by that is when we have 5c to the 3rd, how we can simplify is we can take 5 to the 3rd times c to the 3rd. Then 5 times 5 times 5 is 125 c to the 3rd. And that's how we can simplify that expression. One that's very similar, a little bit more complicated, 5n to the 7th to the 3rd, but we're multiplying 5 times n to the 7th. So that means 5 can be raised to the 3rd power, and n to the 7th can be raised to the 3rd power. 5 to the 3rd, we just saw, is 125. And when it comes to that n to the 7th, we're taking a power to a power. So we have to multiply them together. So n to the 21st. we look at 2xy squared, recognize that inside the parentheses, we're multiplying three things together, the 2, the x, and the y squared. Each of those are going to get squared based on this power on the outside. That means that we'll have 2 that gets squared, and x will get squared, and y squared will get squared. So 2 squared is 4, x squared is x squared, and for y squared squared, we have a power to a power again, and we multiply them to get y to the 4th. Here's a fairly complicated one. It looks pretty messy. 3x squared times 2x to the third to the third. Okay. How we're going to go through it is rely on your order of operations. You remember the order of operations? That's where we started with parentheses, and then we had exponents or powers, multiplication and division, and adding and subtracting. Okay. So if we start with our grouping symbols inside of each of these parentheses, like 3x and 2x to the third, those things are already simplified. So we don't need to deal with that. So now we move on to the exponents or the powers. And if I'm going to take 3x to the second, that means that's 3 to the second times x to the second. For the next one, 2x to the third, we're going to deal with this third power because 2 would be taken to the third power, and x to the third will be taken to the third power as well. So we should simplify each of these. 3 squared is 9, x squared is x squared, 2 to the third is 2 times 2 is 4, times 2 again is 8, and then x to the third, power to a power, we multiply them together and get x to the 9th. Okay. Now we're going to rearrange, because the only thing that's left is multiply, multiply, multiply. I'm going to look at that as 9 times 8 times x squared times x to the 9th, because 9 times 8 is 72. And when it comes to x squared times x to the 9th, we're multiplying these two powers together, so we have to add the exponents. 2 plus 9 is 11. All right, so you might have to work through your order of operations like that in order to simplify a bigger expression.